All right, let's talk about something, well, something wonderfully terrifying. It's called spaghettification. And yeah, it's pretty much the ultimate way the universe can take something apart. It's a process so extreme, it basically pushes our understanding of physics right to the breaking point.
So let me ask you a question, and it sounds like the start of a bad joke, I know. What's the deadliest pasta in the entire universe? Seriously, because the answer gets right to the heart of what happens when you wander just a little too close to a black hole.
And yep, you guessed it, the answer is spaghettification. I mean, the name says it all, right? It's the actual scientific term for when something gets stretched out vertically and squeezed in horizontally until it's just a long, thin strand. Kind of like, well, spaghetti. You might also hear it called the tidal effect. And that's the mystery we're going to unravel today. All right, so how on earth does this even happen? I mean, what kind of force is strong enough to literally shred you apart atom by atom? Let's get into the physics. Okay, so here's the key thing to wrap your head around. It's not just gravity that's the problem. It's the difference in gravity from one point to another. Think about it. Right now, here on Earth, the gravity pulling on your head is basically the same as the gravity pulling on your feet. No big deal. But get close to a black hole, and that all changes. The gravitational field there is wildly uneven. The pull on, say, your feet, if they're closer to the black hole, is going to be way stronger than the pull on your head. And that massive difference, that's what we call a tidal force. And this is where it gets really weird. It's a two-part process. So first, that insane difference in gravity we just talked about starts stretching you out, pulling you longer and longer. But, and this is the crazy part, at the exact same time, gravity is pulling on you from all sides, trying to get you to that single point in the center. So while you're being stretched, you're also being squeezed from the sides, stretched and squeezed all at once until, well, you know. All right, get ready for a twist, because this is where things get really counterintuitive. You'd think a bigger, beefier black hole would be way more dangerous, right? But believe it or not, when it comes to actually crossing that point of no return, the event horizon, the exact opposite is true. Bigger is actually gentler. So let's look at a smaller black hole first, what we call a stellar mass one. Maybe say 10 times the mass of our sun. At its event horizon, the tidal force, that stretching force, is just mind-boggling. We're talking a force equivalent to 800 million kilograms pulling you apart. You wouldn't even make it to the edge. You'd be spaghettified long before you even got there. Now, check this out. Let's go to a supermassive black hole, a monster, 100 million times the mass of the sun. At its event horizon, the tidal force is, get this, basically zero. It is so incredibly gentle that you could drift right across it from our universe into the point of no return, and you wouldn't feel a thing. Not a thing. So what gives? How is that even possible? Well, it all comes down to one thing: distance. The event horizon of a supermassive black hole is enormous. We're talking millions of kilometers away from its center, the singularity. Because you're so far out, the slope of gravity, what we call the gradient, is much, much flatter. The difference in the pull between your head and your feet becomes tiny, almost nothing. So you can just sail right on by. No drama at all. At least, not at first.
Yeah, see, gentle is a very relative term here. Because once you've crossed that line, once you're inside the event horizon, your fate is sealed. There's no turning back. Every single path now leads to the center. And as you get closer, those tidal forces, they are going to climb and climb all the way to infinity.
And it's not just an instant thing. It's a systematic deconstruction, piece by piece. It happens in stages. First, the forces get strong enough to snap your bones. Then, they get even stronger, ripping apart the very bonds that hold your molecules together. After that, your atoms get shredded, the electrons torn away. And finally, as you get horrifyingly close to the center, even the strong nuclear force, the strongest force in the universe, it just gives up. It's overwhelmed, and the nuclei of your atoms are torn apart into a stream of their most basic parts, quarks. Now, I know this sounds like some crazy science fiction, but this isn't just theory. We've actually seen this happen. Not to a person, thank goodness, but we've watched it happen to entire stars. Yeah, back in 2019, astronomers got the best view ever of a star getting spaghettified. This event was called AT 2019 QIZ. Basically, a star just got a little too close to a black hole about 1,000,000 times the mass of our sun. And as the star got torn to shreds, a massive cloud of its own material was just launched out into space at an incredible speed, over 10,000 kilometers a second.
And this was huge, because for the first time, we actually saw this curtain of dust and gas being pulled off the star, and then we saw the huge flash of light as the black hole started to, well, eat it. It was the smoking gun. It proved that our theories about how this all works were pretty much spot on.
But, this whole thing, it brings us right to the ragged edge of what we know about the universe. It's a place where our two greatest theories, general relativity and quantum mechanics, basically declare war on each other. So remember how we said Einstein's theory of general relativity predicts that no drama crossing at a supermassive black hole. You just float right in. Well, there's a problem. Quantum mechanics has this unbreakable rule. Information can never, ever be destroyed. So what happens to all the information that makes you when you fall in? To solve that puzzle, some physicists came up with the firewall theory. They think the event horizon isn't empty at all. Instead, it's a blistering hot wall of energy that would just poof, incinerate you instantly. So no spaghettification, just instant vaporization. And if you thought that was weird, wait till you hear this. String theory has an even wilder idea called the fuzzball conjecture. This theory says there's no singularity, no event horizon, none of it. A black hole is really just a giant, dense, fuzzy ball of vibrating strings. So if you fall in, you don't get spaghettified, your own strings just kind of merge with the surface and become part of the fuzzball. They even have a name for it, stringification. So what in the world is a black hole? Is it a smooth gateway that leads to your ultimate spaghettification, just like Einstein predicted? Or is it a quantum firewall that just torches anything that touches it? Or maybe it's this giant cosmic fuzzball that just adds you to its collection? The honest-to-goodness answer is we just don't know, and figuring it out is going to take a whole new revolution in physics. It really makes you wonder, what's really waiting for us inside?